All right, so we're doing FRQs, which is a huge chunk of the AP exam. There are 6 total FRQs on the AP exam. 2 of them you get to use calculator on, the other 2 you don't. There's a lot of patterns in the FRQs they give, and seeing as how we haven't done all of calculus, we can't do full FRQ questions, so I've kind of modified these. They are taken from the exam, but certain of the questions require us to do second semester calculus, so I've kind of eliminated those and asked some other questions that they usually ask. The hardest part about these is reading it and understanding what it's saying and what's being asked of you. Do like a 3-read approach. Read it 3 times. 1 of them just to understand what's going on, 2 is to get the quantities, and 3 is to try to figure out what's being asked of me, how can I use this stuff. So here we go. A particle moves along the x-axis so that its velocity, right, we're given velocity at time t between 0 and 6 is a differentiable function v whose graph is shown to the right. The velocity is 0 at t equals 3. I'm showing this. At t equals 0, so the velocity is 0 here. At t equals 3 and at t equals 5. We can see that on the graph. Those are x-intercepts, meaning since I'm given velocity, the velocity is 0 at those points. And the graph has horizontal tangents at t equals 1 and t equals 4. So there's a horizontal tangent here and here, meaning the slope of this velocity function is 0 there. All right, so several things to note is we are given the velocity function, which is the derivative of the position function, right? So we're given we're given the derivative of the position, which is the velocity. All right, so part A here is asking over which intervals is the particle moving to the left? Justify your answer. So one of the things to note about these FRQs is you're not meant to do your work in this space, right? That's not nearly enough. So you have to write it on the side somewhere, separate sheet of paper. So part A, when is the particle moving to the left? So if it's moving to the left, then the velocity is going to be negative. Right? Another way of saying this is that v is going to be less than 0. So I'm given a graph here, and I just have to figure out, well, when is the velocity less than 0? And the trick here is you're not looking at whether this graph is increasing or decreasing. We're simply looking at when is it less than 0, because this is the velocity. So you can see less than 0 means below the x-axis. So it's below the x-axis there, and it's below the x-axis there, right? So our velocity will be negative on the interval from from 0 to 3, or another way of saying this is for t values between 0 and 3, and also it will be negative from 5 to 6. You can include 6 there because it's an endpoint. You cannot include 5 because it's 0 at 5. You cannot include 3 because it's 0 at 3. You cannot include 0 because it's 0 at 0, right? But I can include 6 because 6 is a point on here and it's negative. All right, and another way of saying this is 0 is less than t is less than or equal to 6. That's when the velocity will be negative. That's when the particle will move left, right? Negative velocity means it's moving to the left. All right, part B is asking over which intervals is the particle moving to the right? Justify your answer. Oh, just so you're aware, the justification is like writing this velocity will be negative, right? That's how I know, and then showing this. And then part B, over which interval is the particle moving to the right? Well, right is when the velocity is greater than 0, right? So it's when v of t is greater than 0. The particle moves right. And that happens from 3 to 5, not including either one. And again, if you prefer this notation, you can write it like this. On the interval, the t values times between 3 and 5 is when it is moving right, because velocity is positive, right? On this interval. That's a good justification. Right, this little last part is a good justification. Why is it there? Because the velocity is positive in this interval. All right, let's keep moving. Let's do C. At what times does the particle change direction? Justify your answer. All right, so it's going to change direction when it moves. It was moving left and then it moved right. or when it's moving right and then it moved left. Basically, when it, we already have enough information here. So the places where it's going to change direction is, let's think about it, right? When at time equals 0, our particle was moving left, right? The velocity is negative, is moving left, 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 is moving left all the way until 3. The velocity is 0 at 3, and then the velocity is positive, meaning the particle is moving to the right after 3, right? So at t equals 3, the particle changes direction. Why? Because, how do I justify this? Because v of t changes from negative to positive, right? The velocity changes from negative to positive at this value. Okay, and also t equals 5 because the velocity, or v of t, changes from positive to negative, right? It's switching directions because it was going from positive, now it's going negative. All right, let's keep going. D, during what time intervals, if any, is the acceleration of the particle negative? Justify your answer. All right, so here we're trying to find when is the acceleration negative, right? When is the acceleration function less than 0? And this is the tricky part. We are given the velocity, right? So we're trying to figure out, well, if I'm talking about acceleration, how does that relate to velocity? Well, acceleration, if I take the derivative of velocity, then I get the acceleration, right? So the acceleration is simply the slope of the velocity, right? The derivative tells me the slope of a function. If I want the acceleration, I have to take the derivative of the velocity. So to look for the acceleration on this graph, because it's a graph of the velocity, I need to look at the slope of this function. And I need to know, when is the slope, like when is the acceleration negative, meaning when is the slope negative on this function, right? So I'm going to do this in, let's say, pink here. Or let's do blue, teal, whatever color this is. When is it negative? When is the slope negative, right? Or right here, it's negative, yes? So we can say a of t is less than 0 when t is in between 0 or from, we can say from 0, not including 0, to 1. And then where else? Right, that was there. 0 to 1, where else is the slope negative? Well, the slope is negative from there to there, right? From -4 down to 6, right? It's going down, it's decreasing there, right? And from 4 to 6. Right, and again, the alternate notation for this is 0 is less than t is less than 1, and this one is 4 is less than t is less than 6. That's where the acceleration is negative. All right. Next is part E, saying during what time intervals, if any, is the particle speeding up? Justify your answer. So in order for a particle to be speeding up, the sign of the velocity must be the same as sign of acceleration. And so it might be helpful to make a little table here, right? Let's do a little chart like this if we want, and let's break it up in intervals. We're going to be from 0 to 1, and then 3. I'm putting all like these critical points here, all the ones that they basically listed on the front there. 5, and then we end at 6. All right, and up here let's do velocity, and down here let's do acceleration. All right, so from 0 to 1, the velocity is negative, right? It's below the x-axis, and the acceleration is also negative because it has 0 or has negative slope. It's decreasing, right? And then at 1, the acceleration becomes positive because now you can see the slopes are going up from 1 to 3. but the velocity is still negative because it's below the x-axis. From 3 to 4, the velocity is now positive because it's above the x-axis from 3 to 4, and the acceleration is still positive because it has positive slope. It's increasing. Right? Now at 4, we start getting a negative slope, meaning the acceleration is negative, but my velocity is still above the x-axis. Right? And then after 5, my velocity drops below the x-axis, meaning my velocity is now negative, and my slope of that function, the acceleration, is still negative. All right, so we want to know, when is my function particle speeding up? Well, it's speeding up whenever the signs are the same, right? So it's speeding up there from 3 to 4 and from 5 to 6, right? So what we're going to say is the particle is speeding up when t is between 0 and 1 and 3 and 4 and between 5 and 6, because the velocity and acceleration have the same sign they're in these intervals. All right, and that's how you justify that, right? Is explaining it, and the chart up there helps as well. All right, so that is that one. I'll make a different video for some of these other ones.